Welcome, pre-calculus students, to the best hour of your day today, I'm sure. Corey, Chase, Caleb, and Matthew. Hope you guys are ready to learn some math today and take some notes. Oh, wow. Let's see. What kind of announcements do I have for you today? You have a test this coming Monday. No cheering allowed, so please don't forget that. If you're not coming to my house, please let me know. Preferably no later than Sunday night, so I know who's coming and who's not. Test this Monday. You will have a review sheet this Friday. All right, so that review sheet is so important. Those 5 bonus points can lift you from a F to a D to a C to a B, or a B to an A. Also, the reason I'm all for giving you those bonus points is I know how helpful that review sheet is. I'm going to be honest with you guys, a little mean and tough for a second. A lot of you are not coming in here Monday with the review sheet done. And like, okay, I've got questions on 1, 13, 19, 27. You're just coming in here and working on your review sheet. Now, that's your business, but I just don't think that's the best way to get the most out of your education for this class. But anyways, that is your decision. Review sheet will be given to you on Friday. Quizzes were due yesterday, so I am going to have to call some parents, unfortunately, today. I have not heard from everyone. I try not to mention names on a public video like this, but those quizzes were due Monday. I've not heard from some of you. So, and then your integrity sheets, please stay on top of those. If for no other reason, this sounds kind of corny, but do it for me. I mean, it's so much easier for me to get these integrity sheets from you and know exactly how many homework problems you've done. So please stay on top of your integrity sheets and make sure you're getting those done. Now, so far, let me pause here. Go ahead and get your notebooks out. Go ahead and get your pens or pencils, whatever you take notes with. Get your book out. Get your brains out. Get your calculators out. And let's see if we can't have a little bit of trigonometric fun today. We have looked at, so far, basic trig identities. Do you remember those? They were given to you. You should have a trig identity sheet of paper now. And on that sheet of paper, you should be adding trig identities every time we cover some new ones. So far, on your trig identity sheet of paper, you should have the basic trig identities written down. We've also looked at the Pythagorean trig identities. You should also have those written down on your trig sheet. And then, sorry about that. And then today, we are going to look at some new trig identities, and they are called the sum and difference identities. And so now we have 3 parts to your trig identity sheet. Tomorrow, I believe, we're going to look at some identities called the cofunction identities. Okay, so we're going to keep adding to this trig sheet. So without any further hesitation, let's go ahead and take some notes. Your heading today then, because we're looking at these new trig identities, is called the sum and difference trig identities. That's your heading for today. We're still on lesson 6.1. I really feel like we're going good and at a good steady pace, but not too fast. We're trying to kind of go a little slow and make sure you guys are getting this. And so we're still on lesson 6.1. If you want to write the date down, today's the first day in October. So colder weather's coming, which is my favorite time of the year when the weather's a little cooler. And today is October 1st. We're looking at sum and difference trig identities, lesson 6.1. Now, grab your trig identity sheet, please, and let me talk to you about kind of this mess I've made here. Would you do me a favor? Pause the video if you need to. I want you to turn to page 543. Would you do that, please? I want you to do that. Turn to page 543, and at the top, you're going to see the sum and difference identities chart. Now, if you'll look at this page, you'll see they had pluses. I'm going to circle this for you right here. Right here. You're going to see they had like a positive plus and then a red negative sign. Then over here, they had positives and negatives. I just felt like that was confusing. Now that's me. Okay, you're welcome to use that. I thought it was easier. Listen, students. Instead of having the sign of u plus v or u minus v is sum of u or sine of u cosine v plus minus, and if this is minus then you have a minus over here. I just said forget that. That is so hard. They tried to cram all of those identities into one box. So I've broken it down for you like this. If you're taking the sine of 2 angles that you're adding, then it equals this right here. Pretty cool. If you're taking the cosine of two different angles, u and v, it could be something like the cosine of 40 plus 30. Okay? The cosine of 40 plus 30, now we know 40 plus 30 is 70, so the cosine of 40 plus 30 would be the same thing as the cosine of 70. And I'm not dumb, I know that, I get that. But there's a reason we learn these sum properties, and you're going to see why today. They're pretty helpful, actually. But if I had the cosine of 70, and I wanted to break that down to the cosine of 40 plus 30, then I could use this identity right here. Okay? Do you see how it works? This is my u, 40, so cosine of 40, cosine of 30, minus sine of 40, sine of 30, because u is 40 and v is 30. So that's the whole gist of what we're doing here, okay? Let me just erase that. Oh, that takes care of the minuses, doesn't it? Okay, sorry about that. There we go. All right. And so that's what we're doing here. So we have a table right here. I should have done this, by the way, to be honest with you. I should just call this the sum identities, because all of these are adding, and I should have called this down here the difference identities, because down here we're subtracting two angles. So I hope that what I've done has not confused you, but I really did not like how the book put all of these in one chart with pluses and minuses. So I've broken it down for you into two separate sections. One is when you're adding two angles, sine, cosine, and tangent of two angles you're adding. And then another set of identities is when you're taking the sine, cosine, and tangent of two angles that you're subtracting, or in other words, the difference. So these are identities. You need to pause the video and write them on your Trig identity sheet, or photocopy the book, or however you're doing it. That's your business. But these are part of your Trig identity sheet, and you're allowed to have this sheet out when you take tests or quizzes. So it's very important you have a really good Trig identity sheet. Okay? So let's go ahead and take these now, and let's go ahead and start working some problems in which we practice using these. Let's take a look at this first problem. Please copy this problem in your notes. Write this down. Now don't worry about these triangles. You can write them down if you want. We've been over these before. Pi over 4 is 45 degrees. Pi over 6 is 30 degrees. Pi over 3 is 60 degrees. The main thing I want you to write down is this. I want you to find the cosine of 5 pi over 12 using exact numbers. Now the problem here, go ahead and copy that down. The problem with solving this using exact numbers is we don't know the cosine of this angle. In other words, this angle right here in radians, this angle, are you getting this, guys? Listen to me. It's not one of our special angles. Our special angles are pi over 4, pi over 6, and pi over 3. Those are our special angles, but hold it. Hold it. If I can somehow add two angles together, and these two angles here are my special angles, or listen, if I could subtract two angles, and these two angles are my special angles, then I could actually solve this problem. Now, if I'm confusing you, just watch and listen. Watch this. Okay, first of all, I have 5 pi over 12. So I'm going to go ahead and rewrite all of my special angles with the denominator of 12. For example, pi over 4, if I made the denominator 12, then up top I'd have 3 pi. You do see how I did that, don't you? 4, I changed 4 to 12. 4 times 3 is 12, so pi times 3 is 3 pi. I'm going to change pi over 6 so that it has a denominator of 12. If I do that, it would be 2 pi over 12, because 6 times 2 is 12, so pi times 2 is 2 pi. I'm going to change this special angle here so that it has a denominator of 12. Well, 3 times 4 is 12, so pi times 4 is 4 pi. Now, all I did was I just enlarged the fraction. If I were to take this fraction here and reduce it, I would get pi over 4. If I were to take this fraction here and reduce it, I would get pi over 6. If I were to take this fraction here and reduce it, I would get pi over 3. Now, Mr. Earhart, why did you change all of these to a denominator of 12? Guys, what is my denominator up here? 12. So if I'm going to try to find some angles that I can add or subtract, then I better use denominators of 12. And look, I see it. I see it right here. Look, guys, 3 pi over 12 plus 2 pi over 12. If I had 3 pi over 12 plus 2 pi over 12, wouldn't that equal 5 pi over 12? Yes, it would. And look what I have up here, 5 pi over 12. Do you see what I'm saying? So watch this. Watch this. Instead of finding the cosine of 5 pi over 12, I'm going to find the cosine of 3 pi over 12 plus 2 pi over 12. Isn't that cool? I mean, I didn't change anything. 3 pi plus 2 pi is 5 pi. I didn't change anything. And the denominator is 12. So 3 pi over 12 plus 2 pi over 12 is 5 pi over 12. I didn't change anything. Now, let's go back to our trig identities, and look what you have. You're taking the cosine of two angles, and you're adding them. Do you see that? So let's go back to our trig identity sheet. And I'm looking for when I'm adding two angles and taking the cosine. Here it is right here, look. Cosine of u plus v equals this right here. It equals cosine of u, cosine of v, minus sine of u, sine of v. There it is. So when I'm taking the cosine of two angles that I'm adding, I can actually rewrite it with this right here. So let's give that a shot. Cosine of u, cosine of v, minus sine of u, sine of v. So I really have cosine of u, cosine of v, minus sine of u, sine of v. Now I don't have these memorized. Let me check and make sure that's right one more time. Cosine, cosine uv, sine, sine uv. Yep, good. So look at all I have to do now, guys. Look, all I have to do, the cosine of u, well look, this is my u, this is my v. So cosine of u means cosine of 3 pi over 12. Cosine of v means cosine of 2 pi over 12 minus sine of u. Well, sine of u is sine of 3 pi over 12, and the sine of v would be the sine of 2 pi over 12. And we can use exact numbers. Here's your special triangles down here. For example, the cosine of 3 pi over 12. Well, 3 pi over 12 is the same thing as pi over 4, so cosine of this, cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So 1 over square root of 2. 1 over square root of 2. Now we have to rationalize the denominator, so we would really get square root of 2 over 2. Now, how about the cosine of 2 pi over 6? Well, or 2 pi over 12, excuse me. Well, 2 pi over 12 is just pi over 6. So the cosine of pi over 6 is adjacent over hypotenuse. Adjacent over hypotenuse. So square root of 3 over 2. So square root of 3 over 2 minus sine of 3 pi over 12. Well, 3 pi over 12 is the same thing as pi over 4. Sine is opposite over hypotenuse. Opposite over hypotenuse. Opposite over hypotenuse. So 1 over square root of 2. Now we know that 1 over square root of 2 has to be rationalized, and you would get square root of 2 over 2. Square root of 2 over 2. Now let's take a look at the sine of 2 pi over 12. Well, 2 pi over 12 is the same thing as pi over 6 right here. And so the sine of pi over 6 is opposite over hypotenuse. Opposite over hypotenuse, 1/2. All right? So for here I have 1/2. And look at that. Look at that. Now we're really moving along. Square root of 2 over 2 times square root of 3 over 2. Well, you multiply top times top. That gives you square root of 6 over 2 times 2 is 4, so square root of 6 over 4 minus square root of 2 times 1. Square root of 2 times 1 is square root of 2, and 2 times 2 is 4. All right, now we're almost done. Look, students, I'm not sure if you remember this from Algebra 2, but look, you cannot add or subtract these two radicals. They're unlike terms. Now, if this was square root of 6, you can take square root of 6 minus square root of 6. That's fine. Okay? If this was square root of 2, then you could take square root of 2 minus square root of 2. But we have square root of 6 minus square root of 2. They're unlike terms, so don't combine them. Just put square root of 6 minus square root of 2 all over your common denominator, which is 4. And you are finished. So you just found the cosine of 5 pi over 12 using exact numbers. And here's your answer right here. Now, how did you do it? Well, you realize that 5 pi over 12 is not one of your special angles down here. So you took your special angles and you saw two of them could be added to give you 5 pi over 12. So instead of using 5 pi over 12, you use these two angles right here, and then you use this sum trig identity. Pretty cool, pretty helpful. All right, let's go on to the next problem. Copy this problem in your notes. I would like you to find the sine of 105. Now, if these words weren't here, it would be easy. You would just grab your calculator and type in the cosine of 105. But unfortunately, it says using exact numbers. Now, go ahead and copy this down and listen while you're copying this problem down. I mean, first of all, you got to realize something. 105 degrees is not one of our special angles at all, okay? I mean, not even close. So we have 45, 30, and 60. Those are our special angles. So if we're going to use exact numbers, somehow we're going to have to manipulate this and do some changing here. Well, the first thing that I see is sine of 105. Can I take any of these angles and add them together or subtract them and get 105? And the answer is yes, of course. Look at this. What is 45 plus 60? That's 105. So instead of taking the sine of 105, I'm going to take the sine of, and it doesn't matter which one you put first. In the previous problem over here, it did not matter which one you put first. You could have put 2 pi over 12 plus 3 pi over 12, and you would have got the exact same answer. So you can put 45 plus 60, or you can put 60 plus 45. So if I take the sine of 45 plus 60, that's the exact same thing as taking the sine of 105. Now let's go back to our trig identity page here, and look, we're taking the sine of two angles that are being added. The sine of two angles that are being added. So let's see. Here it is right here. Down here we have the sine of two angles that are being subtracted, and that's not what we're looking for. Here we have the sine of two angles that are being added. This is what we're looking for. So the sine of u plus v equals sine u cosine v plus cosine u sine v. So sine cosine uv plus cosine sine uv. All right, so here we go. Let's go ahead and write this down. We have the sine of u cosine of v plus cosine of u sine of v. Now, I don't have these memorized. I want to check and make sure I got this right. Sine and then cosine, cosine, and then sine. Sine, good, we're good. All right, so here we go. Now that we have broken down 105 into these two angles right here, this is going to be my u, this is going to be my v. So the sine of u would be the same thing as the sine of 45 degrees times the cosine of 60 degrees plus the cosine of u, which is 45 degrees, times the sine of v, which is 60 degrees. And now let's just plug these things in and we're good to go. The sine of 45. Here's 45, opposite over hypotenuse. Opposite over hypotenuse. So the sine of 45 is 1 over square root of 2. Of course, 1 over square root of 2 has to be rationalized, and that would be square root of 2 over 2. Now let's take a look at the cosine of 60. The cosine of 60. Here's 60, adjacent over hypotenuse. Adjacent over hypotenuse. All right. So we get 1/2 plus, now the cosine of 45. Come over here, adjacent over hypotenuse. Adjacent over hypotenuse. 1 over square root of 2. Of course, we have to rationalize that, and we get square root of 2 over 2. And then the sine of 60. Well, opposite over hypotenuse. Opposite over hypotenuse. Square root of 3 over 2. And men, we're just about home free. Multiply these two together. Square root of 2 times 1 would be square root of 2. 2 times 2 is 4. Plus, square root of 2 times square root of 3 would be square root of 6. And 2 times 2 is 4. Did we get the exact same answer over here? Almost, okay. And then we do have a common denominator, 4 and 4, so we can add these two fractions. Notice the square root of 2 and the square root of 6 are unlike terms. They're not the same, so we cannot add them. We can just write them side by side. So the square root of 2 plus the square root of 6 all over 4. There you go. You just found the sine of 105 degrees without using a calculator, using exact numbers. And you did that by realizing 105 is not one of your special angles, but you realize you could break it down into two special angles that are being added together, and then using your sum trig identities, you could then go ahead and solve this problem. I think that's pretty cool, pretty nifty. All right, to use an 80s word. Okay, moving on to your next problem here. Hopefully you're getting some good practice with this, because this is really, really important for you, okay? Okay, copy this problem in your notes, please. We are going to write this given problem right here. We're going to write this as a trig function, look guys, of a single angle. Then we're going to evaluate it with a calculator. Now, right now, we have trig functions using how many angles? Not 4, but 2. 40 degrees is one of your angles, and 15 degrees is the other. Do you see what I'm saying? And that's not what they want. They want us to rewrite this so that we have a trig function of a single angle. Can I put this in English for you? They just want us to go backwards, okay? Let me show you what I mean. Look at your trig identity sheets. They're giving you the right side over here. They're giving you the right side, and they want you to come up here and write it as the left side over here. That's all they want you to do. So now we're going to go backwards. And it's not difficult. In fact, it's easier than what we just did. So let's look at what they've given to us. They've given us a problem. Now look, students, they've given us a problem that says sine of 40, cosine of 15. Cosine of 40, sine of 15, minus. Now you know this is your u, and this is your v. This is your u, and this is your v. Do you see that okay? So what we really have is sine of u, cosine of v, minus cosine of u, sine of v. Now we've got to find this somewhere special back on our trig page over here. In fact, I'm going to do this to help us. I'm going to go like this, and I'm going to highlight this thing. I'm going to grab it, and I'm going to drag it right over here to this sheet. There we go. Now, let's see if we can match this up. Sine u, cosine v, cosine u, sine v, with a subtraction sign right here. Let's see if we can match that up with one of these trig identities. Here we go. Sine, cosine. That's a plus sign. That's cosine, cosine. Hey, here, look right here, guys. Here it is. Look, sine of u, cosine of v, sine of u, cosine of v, minus cosine of u, sine of v, sine of v. Cool. So we found, let me get rid of those lines. We found the identity we wanted, and it's this one right here. There it is. Now, if you'll look, whenever you have this right side right here, like we do right here, whenever you have that, please notice it's the exact same thing as, hold on one second please. Okay, thank you. All right. It's the exact same thing as this over here. So this whole expression that I have right here, this whole expression can be rewritten as sine of u minus v, sine of u minus v. So let's go back to our page. And now this whole expression right here can be rewritten as sine of u minus v. Remember, we saw that right here. Sine of u minus v equals sine u cosine v cosine u cosine v. Now, what is u? 40 degrees. What is v? 15 degrees. So I really have the sine of 40 minus 15, which really is the sine of what? 25 degrees. 40 minus 15. So the sine of 25 degrees equals all of this right here. And look, you did what they asked you to do. It says write as a trig function of a single angle. And you did it. Here's your trig function, and here's your single angle, 25 degrees. So you did it. So we took this entire huge mess right here, this whole mess right here, and we broke it down to this right here. Very cool. Now I'm going to tell you something. I'm not a lazy teacher, but I'm sitting here with a microphone on my head and a headset and all of that. And I did not bring my calculator with me. It's somewhere in the house. So I'm not going to type this in, but we really know how to do that by now, students. I really think. Because look at the rest of the problem. It says then evaluate with a calculator. I mean, just make sure you're in the degree mode. Push your mode button. Make sure you're in degrees. And then type in sine of 25, and you'll get out the decimal answer, and you can write that right there in your notes, okay? So a pretty cool problem. Here, we went backwards. So it's really, really good, students. They're making you think, okay? All right, let's try. I believe it's one more problem, I believe, and then we're ready to start your homework, okay? So let's take a look at one more problem. Okay, while I'm rambling, go ahead and copy this in your notes. Assume that sine of x equals 2/3 and sine of y equals 1/3. Also, we're going to state that x and y are between 0 and 90. Now stop right there. All that means is you're in the first quadrant. Okay? And the reason that's important, that means all of your signs are positive, positive, positive. Don't get hung up on that. That's not a big deal. Okay? They just put that in there to be technically correct. Okay? So sine of x is 2/3. Sine of y is 1/3. Then evaluate the sine of x plus y. So they want you to evaluate the sine of x plus y. Okay? Now, think of your trig identities. And again, I don't have them memorized. I wish that I did. Sine of x plus y. Let's go back about 4 pages and look at this. Here's the sine of u plus v. Now, we can call that x plus y. That really doesn't matter what the variables are. You understand that, I hope. But the sine of two angles that are being added, and in our problem they're being added, the equivalency to that statement is sine u cosine v plus cosine u sine v. So sine, cosine, cosine, sine. So let's go ahead here. So what I can put is sine x cosine y plus cosine x sine y. Now I'm going to check it again to make sure I'm right, but I think it's right. Yep, sine cosine plus cosine y. So sine of x plus y equals this. So now I'm going to use this right here to help me solve the problem. Well, Mr. Earhart, how are you going to do that? You don't know what the sine of x is or the cosine of x or y. Yeah, I do right here. Look, I gave it to you. This is so easy. Sine of x equals 2/3. So sine of x, parentheses, that's going to be 2/3. All right. And then also they give us the sine of y is 1/3. So I come down here. The sine of y is 1/3. All right. Now, watch this carefully. It looks like I'm kind of in a little bit of trouble, because I don't know what the cosine of y is, and I don't know what the cosine of x is. But students, come on, yes you do. Look, you know what the sine of x is, don't you? It's 2/3. So I'm going to draw a right triangle real quick. I'm going to put angle x right here. It doesn't matter where you put it. I'm going to put it here. Okay? Now, the sine of x is what? 2/3. Let me say that again. The sine of x is 2/3. So here's x. So the opposite side has to be 2, and the hypotenuse has to be 3. Where'd that come from, Mr. Hart? Right here. You're 2 and you're 3. The sine of x is opposite over hypotenuse, 2/3. Now, I'm not going to use Pythagorean's theorem for it, but if you use, we have to use it, but I'm not going to take time and do it. I'll tell you what, I'll do it real quick for this triangle. The next triangle I'm not going to. Using Pythagorean's theorem, L squared plus L squared equals 8 squared. One of your legs we don't know. The other leg is 2. The hypotenuse is 3. So we have L squared plus 4 equals 9. Now subtract 4. L squared equals 5. And now take the square root of both sides. L equals square root of 5. So we just found the missing leg, and it's the square root of 5. There we go. Now, why is that helpful? Are you kidding? Now we know what the cosine of x is. Here's x. What's the cosine of x? Adjacent over hypotenuse. Adjacent over hypotenuse. So square root of 5 over 3. So cool. Now, the only thing left for us to find is the cosine of what? Y. So let's draw us a triangle with angle y. Here's y. Now, we know the sine of y. Look, they gave it to us. So here's y. The sine of y is 1/3. So here's y. The sine would be opposite over hypotenuse. So cool. Opposite over hypotenuse. Now, trust me, if you'll use Pythagorean's theorem, you will get square root of 8. But hold it, guys. Square root, remember in Algebra 2, square root of 8 is not really helpful. I mean, it's helpful, but it's not simplified. Remember, there's a perfect square. There's a number that we know the square root of that goes into 8. So I can rewrite 8 as 4 times 2. Now, why would I do that? Well, I don't know the square root of 4, but I do know this, I don't know the square root of 2, but I do know the square root of 4. So the square root of 8, if you use Pythagorean's theorem, trust me, you'll get square root of 8 right here. And 8 is the same thing as 4 times 2. And I do know the square root of 4. The square root of 4 is 2, so I put a 2 on the outside, and I'm left over with a 2 on the inside. So to be honest with you, instead of using the square root of 8, I'm going to use 2 square root of 2. 2 square root of 2. So now I know the cosine of y. We do? Yeah, here's y. Adjacent over hypotenuse. Adjacent over hypotenuse. So the cosine of y is going to be 2 square root of 2 over 3. And then plus. All right? So here we go. Let's multiply 2 times 2 square root of 2. Now this is a number that's not inside a radical, it's on the outside. So you multiply outside numbers times outside numbers. So 2 times 2 square root of 2 would be 4 square root of 2. 3 times 3 is 9. Over here, square root of 5 times 1 would be square root of 5. And 3 times 3 is 9. Now add those two together. Of course, 4 square root of 2 and square root of 5 are unlike terms, so we cannot combine them, but we can write 4 square root of 2 plus square root of 5 all over 9. And that, in my opinion, although you might disagree with me, is really cool math. So what have we done today? We have learned new identities, the sum and difference identities, and we've applied them to different problems. And that's really, really helpful. Okay, here's your homework. And again, guys, I've really tried to make this reasonable. I know that it's not easy to do. Okay, I've given you a total of 12 problems. Now that's decently reasonable. Okay, I want you to do 51 through 61 odd. That's 6 problems. And then 55 through 65, that's 6 more problems on page 545, okay? So there is a homework help video to help you with this in case you're struggling. I hope you guys have a good rest of the day. Call me or email me if you have any questions on your math.